Welcome to Star Chat, the podcast where we explore the wonders of the universe and bring you the latest news from the world of astronomy and space exploration. I'm your host, Carl, and I'm excited to share some fascinating stories with you today. We've got a great show lined up for you, but first, let's talk about a recent discovery that's been making waves in the scientific community. You might have heard about a new study that suggests there could be a large population of rocky planets, including super-Earths, orbiting stars at distances similar to Jupiter's and beyond. These planets would likely be icy, with surface temperatures well below freezing, and could be quite different from the Earth-like planets we're used to thinking about. The study used data from the Korea Microlensing Telescope Network to detect a microlensing event, which occurs when a star passes in front of another star, causing a gravitational lensing effect that can reveal the presence of a planet. In this case, the team detected a small bump in the light curve that suggested the presence of a planet with a mass about 1.3 times that of Earth, orbiting its star at a distance roughly similar to Saturn's. Now, you might be wondering what this means for our understanding of planetary formation and the search for life beyond Earth. Well, it's still early days, but this discovery could have significant implications for our understanding of how planets form and evolve around other stars. If these icy super-Earths are common, it could mean that there are many more potentially habitable worlds out there than we previously thought. But before we get too excited, let's keep in mind that this is just one study, and there's still a lot we don't know about these distant planets. The team behind the study is cautious about their findings, and they're eager to gather more data to confirm their results. We'll be keeping an eye on this story and bringing you updates as more information becomes available. In the meantime, let's take a break and come back with more fascinating space news. We've got stories about black holes, cosmic collisions, and much more, so stay tuned. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat, folks. We're diving into the fascinating world of space exploration, and today we have an exciting update from NASA that's sure to captivate your imagination. As you know, NASA's Artemis campaign is gearing up to send astronauts back to the moon, with the ultimate goal of establishing a sustainable presence on the lunar surface. But before they can set foot on the moon, scientists need to better understand how the rocket exhaust from the landers will interact with the lunar regolith. Imagine a massive rocket engine igniting and sending plumes of hot gas shooting out onto the moon's surface. It's not just a matter of blasting off into space. The exhaust can create craters, instability, and even send regolith particles flying at high speeds in all directions. To tackle this challenge, engineers at NASA's Marshall Space Flight Center have been test-firing a 14-inch hybrid rocket motor over 30 times, simulating the conditions that the landers will face when they touch down on the moon. The testing is crucial because the Artemis landers are much larger and more powerful than those used during the Apollo missions. The data collected from these tests will help scientists anchor their models and better understand the physics behind the interaction between the rocket exhaust and the lunar surface. This, in turn, will make landing on the moon safer for the astronauts. The hybrid rocket motor, developed at Utah State University, is a remarkable piece of technology that ignites both solid fuel and a stream of gaseous oxygen to create a powerful stream of rocket exhaust. The testing has been conducted under vacuum conditions, simulating the harsh environment of space, and will continue later this year at NASA's Langley Research Center. As we continue to push the boundaries of space exploration, it's incredible to think about the complexities involved in sending humans to the moon and beyond. The work being done by NASA's engineers and scientists is truly pioneering, and we can't wait to see what the future holds for space travel. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. We've had an amazing conversation so far, exploring the wonders of the universe and all its secrets. As we wrap up today's show, I want to share with you a fascinating story that's out of this world, literally. You know how we've been talking about the moon and its mysteries? Well, it turns out that our lunar companion has a secret. It's making water. That's right, folks. the moon is producing water, and it's all thanks to the solar wind. This stream of charged particles from the sun is bombarding the moon's surface, creating hydrogen atoms that then bond with oxygen to form hydroxyl and eventually water. Now, you might be wondering how scientists figured this out. Well, they used some pretty cool technology to test the theory. They took samples of lunar material collected by Apollo 17 astronauts back in 1972 and subjected them to a simulated solar wind using a particle accelerator. And guess what? They detected strong signals of hydroxyl in water. This discovery is not only exciting, but also important for future space missions. If we can harness this process, it could provide a source of water for astronauts on the moon, or even beyond. Imagine being able to produce water on demand, using the sun's energy to sustain life in space. It's a game changer. As we continue to explore the universe and push the boundaries of human knowledge, stories like these remind us of the awe-inspiring complexity and beauty of our cosmos. So, the next time you look up at the moon, remember that it's not just a rocky satellite. It's a dynamic, water-producing world that's full of surprises. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.